Okay, so hello everyone. This is our fourth. Fourth? No, I'm gonna lower the volume on my, just to keep the listening to the chat. Okay, this is, I believe, our fourth beginner lecture. Yes, this is our fourth. So this is our fourth beginner lecture, and today we're gonna talk about recursion. We sort of discussed it in the arrays sorting lecture, which I used merge sort, and the merge sort algorithm actually has to call itself. And that's what recursion is. It's a function that calls itself. Let me give you an example. So I am going to write the pseudocode in Python, and I know some people don't know it. If you have questions about it, actually, can I get the, let me use the other marker, see if this one's better.
You want to go to the document real quick?
No.
I know that's
Oh, I think it should be, this one, this one's done.
okay, yeah, that's good.
And then I think it
no,
went
no,
here.
one. Shall we want this little bit this way? Tiny bit.
Bruh.
Okay,
Yeah, that's enough out of you. That's enough out of you.
I'm done.
Yeah, that's enough out of you, man. Last row is just trolling, dude. So in Python, we have functions and we define them by def, right? And I'm gonna calculate, I guess we're gonna start with Fibonacci. Okay, this is, yeah, so. So, well, before I actually make the function, I wanna say that the Fibonacci sequence goes like this. So it's like a list, so f0 equals, I'm gonna start at 0, f1 equals 1. And so f of n equals f of n minus 2 plus f of n minus 1. So this is a recurrent solution. So the number you're on is equal to the, the previous two numbers. So the one right before it and the one right before that one. And it's the addition of those. So if f of 0 is 0, f of 1 is 1, f of 2 equals f of 0 plus f of 1, f of 0 is 0, f of 1 is 1, it's 1. F of 3 is f of 2 plus f of 1. F of 2 we solved it was 1. F of 1 we solved it, well, is there. It's 1, it's 2. F of 4 is f of 3 plus f of 2, 2 plus 1, that's 3, and then so on. Any questions on this? Nope. So how do we write this function here, right? So we know that it's going to call on itself, right? But we have to make it stop at some point. Well, before I get to that, let me actually write the recurrence part. Okay. Does that seem like what we did? Okay. So if I put I'm gonna put 2. How long is that gonna take when I run this?
So there's only one step.
Which step?
F of 0 and f of 1.
Mm-hmm. All right, so f of 0 is given, f of 1 is given. But if I plug it in here, what happens? It's going to go to negative numbers, yes. I'm glad you caught that. So before we write the recursive function, we need to add a stopping point, which is the base case. This is when we stop calling itself. So what do we say? N, if n is 0 or n is 1, return n. Or 1. Do we agree on this? Okay. So now what's going to happen? How long is that going to take?
I know what it does, I just don't know how to answer it.
Okay, well,
When you plug into it's gonna return Fibonacci of 1 and of 0.
Yeah.
And then it's gonna evaluate again and return
yeah. So then
0, 1.
So then this is going to return of 1 to this part right here. I actually flipped it. I was supposed to do it the other way, but it doesn't matter.
And that's Fibonacci of 0.
So how long does Fibonacci of 1 take to run?
Constant.
Exactly. This is constant time. So this is going to return 1, and this is going to return 0. So 1 plus 0, and you give it to that. Okay? So now what if I put 3 instead? Well, these numbers obviously change, right?
2 and 1.
2 and 1. Okay?
And 2 is 0 and 1.
Okay. But did I say that here in this function? Does the function know that fib of 2 is actually 1?
No.
It does not know. So it's going to call itself again, like it does. Since n is not 0 or 1, it's going to do the whole thing. So then this is going to be T0. Okay. Well, this is going to return 1. But see, Fibonacci of 2 had to do the whole recursive function again, right? And obviously this is going to return 1 and 0. So it's 1 plus 0 plus 1. Do you see a problem?
Yeah, so f of n would be n, like n times.
Well, actually, so you're saying that you have to run it again? Look at this part. How many times do we have to calculate this?
3.
Fibonacci of 1. How many times do we have to get this value?
2.
We have to get it 2 times. Why do we have to get it 2 times?
It's calling itself.
So it's calling itself, right? So Fibonacci of 1 is 1, but Fibonacci of 2 is Fibonacci of 1 plus Fibonacci of 0. But we already saw Fibonacci of 1, right? So there has to be a way to prevent calling, like, doing the same calculation. Goodbye. Anyway, there has to be a way to avoid doing this later. Right? To not have to calculate the same value again. So what can we do? Before I give it away, what can we do? I'm gonna erase this part. Actually, I'm gonna leave this.
Save it into an array or something?
Yes. Good job.
So then you just again return the sum of the array. Or something like that.
It's not a bad idea, actually. So we could do that. Well, I want to do it recursively first. Yeah, you're actually right. This could be done without using recursion, but this is the recursive lecture, so we're going to use recursion. So what he said was make an array, right? And populate it with values. So this is the fib array. Okay. And then we know that because of this is 0 and 1, and then we have to populate it. So let me see. So one thing I can do, fib is not going to give you negative numbers, so I'm going to fill all this up with negative ones. This is 0, 0, 1, 2, 3, 4, 5, 6. Okay. So we're going to calculate Fibonacci 6. So why don't we do this? What can we improve here, right, in this function to make use of this array? Actually, while I'm at it, fib, let me call this fib r. So what can we do there? To improve this.
Instead of returning, you could write at the end fib of n minus 1 plus n minus 2.
Yeah. So we can still keep this, actually. We can keep this. So which values were filled in the array?
0.
So yeah. So instead of n equals 0, n equals 1, we could say, since it's already filled, we could say return that, right? There's something else, actually. We can improve this if statement, because this is only calculating it for 0 and 1. But this means, well, how do I check to see if a value is filled or not? Based off of that array.
With the size?
No, not the size. How do I know that the fib value at,
Oh, as long as they're positive?
oh, yes. So if it's negative, right? So if it's less than 0, right? So you could say, check the array itself. Well, check if it's right. So if it's greater than or equal to 0, that means that, if it's greater than or equal to 0, that means that we did work on it, right? So that means return fib n, all right? And we can still keep this. So let's do Fibonacci 6. All right? So that will come out to right. This is going to be pretty long. This is going to be pretty long. I did not prepare for this. 4. Okay. All right. Okay. So just pretend this is a recursive tree. I know this looks kind of bad. Who's confused by the way I drew this? Let's just be clear. Who's confused by this? So maybe this will make it clear what I'm doing. Okay. Is that
Wait, no, never mind. I forgot the size. Like, people can't see the size.
people can't see this?
As in, like, those sides. Like
Yeah, they can't see. They can see from that line to this line.
Yeah, I was going to say, like, do it more like a tree.
Yeah. So this is a tree. This is a tree.
No, but, like, more tree shaped.
Yeah.
No,
Oh, right.
No, it's okay. You already did it. It's okay.
Yeah, this is tree shaped. Okay, and then this.
Yeah, maybe make it more tree.
I can't. I have no space.
Oh.
I have no space. That's why I'm doing it like this. Okay, so look, this is a tree, right? Fib 6 is equal to fib 5 plus fib 4. All right? And then fib 5 equal to fib 4 plus fib 3. Okay, but let's just go down one side. Fib 6, fib 5, fib 4, fib 3, fib 2, fib 1. Okay. So now we see this, right? So the value at 1 is not negative. That means it was done. So instead of doing, well, actually this is going to be fib 1, which is the same as 1. So, and then that's going to go back to 2. So then I'm actually going to erase this because this is ugly. This is ugly. This is ugly. Okay. Right. So Fibonacci 2, I'm going to abbreviate it to F1, F0, which is these two, right? We tabulated. Oh, and then I just caught myself on this. We overwrite the array, right? And that's what we return. All right. So what does this do? This gets the values and puts it into the array. So F1 and F0, fib1, fib0 is 0 plus 1. So then in the recursive call, I overwrite and I put the 1 there. Okay? So what about fib3? When I do fib3, right, I would have to do before okay. So fib3 is Fibonacci 2 plus Fibonacci 1. Before, I had to calculate Fibonacci 2 by doing F1 and F0. But I filled the array. I filled the value. So instead of doing this, I give it the value of the array. And this one. And then here, I say can they still see this part?
Yeah.
Okay. Does this make sense so far? Are there any confusions yet as to why I'm doing it in an array? No? Okay. So before, actually, let me do fib4 to see. Fib3 is 1 plus 1. So in the array, I put 2. Okay. So fib4. Fib4 is 2 and 3. And before, I would have to do 2. Okay, fib4, right? Before, I would have to call fib3 and fib2, and then fib3 inside we'll call fib2 and fib1, and inside we'll call fib1, fib0, right? And then I calculate, and then I come back and I have to calculate fib2, which I already did it before, and then do a whole tree and make it, really long and really complicated. So what I did instead is that instead of doing this, where I have to, call a lot of values and make a lot of calculations, I just get it from the array. See? It's filled up. So all I have to do is a constant runtime at this iteration. I just add, the two tabulated values, which is 2 and 1. I don't know if that looks like a 2. I'll make it more clear. Okay? Is it more clear now why I'm putting it in a table now? Okay. So it's to avoid having a whole big tree where I have to recalculate values. I have it stored in the table so I can just reference it when I need the values again. I don't have to do all the work, 1,000 times. So this is the optimal memoized solution for Fibonacci. So the recursive part was gonna take really long, right? Where it was, I had to fib2 is fib1 plus fib0, or fib3 is fib2 plus fib1, but fib2 is also fib1 plus fib0. And now, because before that was going to take exponential time. Now this is going to take linear time. So the amount of time taken to solve this problem was immensely reduced. This is the optimal solution for recursively solving Fibonacci. And what I did was called memoization. Right? Okay. So then, of course, I would go all the way. 3 plus 2 is 5. 5 plus 3 is 8. And if I wanted to get fib6, since fib n is greater than or equal to 0, that means it's calculated. Because before it was -1, so that means we didn't do work. Okay, so this array that we made would be called the memo table, right? That's what this is. This is the memo table because we want to make a memo of what we've already, calculated. And then this is fib. There is a way to solve fib without using recursion, with just the for loop and just the array. I think fib is on LeetCode. We're gonna give that out. So try, yeah. So it's ironic that I'm teaching you recursion, but try to solve it without recursion. I already gave the answer.
Do you have 2 returns on that function?
This is no. There's only one. Well, this return. Oh, okay. So basically, in the if statement, right? If it's greater than or equal to 0, return this. And when you return, you escape the function. So that means all of this is skipped. You skip everything after this return. Yeah. So and if this is not true, you just skip this if statement. This return is skipped, and you do all of this. All right. Any questions before we move on?
That's still recursion, right?
This is still recursion because we're still calling the function on itself. Right. What we just did was optimize it to have a table so that we don't have to recalculate values. This is memoization. Memoization. And that is not a typo. That is actually what it is because we use a memo table. Okay. Before I move on, let me see how much time we have left. Oh, okay, we still have time. Let me read the problem again. So I'm going to give you guys a problem, right? Which is an interesting one. I did it today just to see what I could give you. But this is a problem that could be solved without recursion, but recursion is really useful because that's how we actually kind of visualize it. So it's called decode a string. This is on LeetCode, by the way. We're probably gonna give it out too. This is a medium question. Decode string. I'm gonna call it decode string. right? And so the idea is that you get a string, and in the string, you have like a sort of notation to, generate another string following like the pattern. So this is how it works. So this string has this number, and this number has what is it? This is a brace or a bracket. This is a bracket. This is a square bracket that surrounds another string. And the point is that this actually returns this. This number tells you how to repeat what's inside. I'm going to give another example. So if it was AB, oh, sorry. It was AB. What would that give you? Yeah, so this will give you AB, AB, AB. And sometimes they might even throw you something hard like that. What about then? I'm sorry, Hermes. This is yeah, so you can solve the inside first.
CD, CD.
Yeah, so let me do that. So 3 A B. You said CD CD?
Yeah.
So CD CD, because CD is twice. And we could probably do this. And this is 2F. So I just did that. And then we do this one, right? And then we just put this one 3 times. A, B, C, D, C, D, A, B, C, D, C, D, A, B, C, D, C, D, F. And it gets really long. So what did we do? So you saw how you did it, right? One of the people here, you said to do the thing inside first. Isn't that kind of recursion? You're doing the sub problem and then expanding to the bigger one. So that's what he said. We work on this smaller one, so then we can work on this bigger one. And that's exactly what we're going to do. So I'm going to erase this. Maybe I'll leave that. So this problem involved a stack. Let me see if I'm going to, do I have space? I'm going to, actually might erase this as well. I'll put this one here. Yeah, we discussed stack briefly. Most of that lecture was quicksort, which was not intentional. That was not what I wanted to do, but it ended up, yeah, it ended up being that way. And literally everything is off the cuff. I don't plan any of this. I plan none of this.
You're saying that in front of the president. That's awesome.
Yes, I'm sorry. Well,
David, after this, 5 minutes.
the president's going to give me a lecture after this. Yeah, but no, I did prepare this problem.
No,
This problem is prepared. Actually, I am looking at the code right now, which is my solution
So
for it.
wait, you don't know the code yourself?
I do. But I'm just making sure that I translate it to something, because they do Java, not Python, and I have to make sure that they can read it, and it's not something that is purely Python and,
Wait, okay.
No, but these two don't. These two don't do Python. Oh no, you you prefer Python? Great, awesome, yeah. Sorry, Azar. So string s. Okay. So first we have to iterate. Well, This is going to be, well, I'll call it recurse. S. So we have, well, actually, before I start, I guess I'll just briefly, you know about strings, right? And how strings have like subsections. This is for the Java people. So this string list, let's say it's equal to, no. Labrador. It's a good dog. So I can cut it up into pieces. And a string is just an array of characters. That's all it is. And each character has an index, 1, 2, 3, 4, 5, 6, 7. Right? It has 7, well, it has 8 characters, but it's 0 index. So I'll say 2. If I say something like this means that I want to take the string, but starting from number 2. So, bye. That's what this notation means. This is the start, and the end, well, it just goes to the end, right? Any questions about this? Okay. We don't really need to go over this, but you can, specify the end here. Two, 3, 4. Actually, I'll put it in there. So do you think this is correct?
I think it depends on like the definition.
Yeah, the notation.
The upper bound is included.
No. So that's a good question to ask. Is the upper bound included? No. So it's actually excluding that value. So
The lower one is included.
yes, this is included. It starts at 2 and it ends at this one minus 1. This one minus 1 is included. This one is not included. Okay. Okay. Just so we have we know what is it? String splicing. The string slicing.
Oh, is it slicing or splicing?
I don't know. Cutting up the string. Is it? Do you know? Slicing.
Yeah.
String slicing. So that's basically how string slicing works. Yeah, I'm not gonna go too in depth. I didn't need to actually know that much. And we know, so in Python, we don't have to say what the type is. It could be anything. Let's say I, J. So this would be like a tuple. And a tuple is just like a pair of values. So I could put 0 and 1, right? So this 0 will go to this I, and this 1 will go to this J. And that's how it works. And you really don't need the parentheses at all for either. I mean, Python just knows that that's going to be like a tuple, and it'll assign it. And you can even decouple this tuple and just, what is it? No. You can print I, and it's going to, what's that going to give you?
0.
Yeah, it's going to give you 0. Okay. All right, so we got that out of the way. So here, on S, no wait, this is return. Let me see that I did write this correctly. Is P, Oh, another thing that I forget to mention. Since this is a tuple, I'm just going to call it, this tuple equals to 0, 1, I can actually access the values of that tuple by array indexing. So what's that going to be?
0.
Yeah, and so what's this one going to be? Oh yeah, it's a 3, yeah. So this is the 3. Okay, all right, so we got that out of the way. Because we're going to make the recursive function return a tuple, and we're going to return the first value of that tuple, and I'll explain
So
what that
the
means.
return is recurse
Yeah,
of s comma 0.
I made a mistake here. I'm going to call it position, pos. Right, and then here's the function that we defined before. And we start with the iterator, number, and then 0. Okay? So I is going to start at the position. So at first, when we recurse, it's going to start at 0. So this is like it's like a for loop, sort of. Not really. But we always start in the string at the first position is just 0, which is what I is. We're going to iterate. Is that confusing a little bit? Is that a little confusing?
So recurse is going to return an array, right?
It's going to return
No, a tuple.
a tuple. Yeah, so it's going to return a 2 values, right? So it's going to be, what is it? Well, actually, the first value is the string, which is all put together. The second value is a position, which we do need because, let me actually give you an example. We kind of do need a position because we need to get this position, right? And then from this position, we want to, since we are going to make this a, we want to add it to this subproblem. And then we want to skip this bracket to add f and d. So we need to make a note of what position that we escape from, which is this one in this case. And we want to go to f and d, and then we want to escape from this again, and so on. So that's why it has to return a tuple and not just the concatenated string. And concatenated just means to add, the string together. Okay. Let me see. Oh, and in Python, not H, I'm doing this. This is a function called len, which is short for length, and it takes in a string or an array, right? And that's all it does. So it's checking if I is less than the length of the string. So we're iterating through the string. So first, if so s is a string, s is just an array, so we can get the index, right? Put the index in s, and that returns us the character that is at s. So the first thing we check is if it's a number. That's the first thing we check. So is it a digit? And a digit can go from 0 to 9. Okay? So this is the number, right? We have to keep track of the number, which is 0 at first. So we say that the number is equal to the number times 10 plus okay. So first the number is 0 times 10 is 0 plus the number that the character is. It's a digit, so you add that. So the point that we're doing this is that you can get I'm gonna make it simpler. So let's say we have 35, right? And we're iterating through each character. What we need to do is that we need to get this whole 35. Instead of just like 5 and then add 3, no, we need to get 35 of these, which includes A, and 42 Bs, right? So we need to add up all of the digits, and then from there, that's when we're going to call it recursively. We have to add all the digits up together. And in order to get the proper number, so our first number is 0, then you multiply that by 10, and then you add 3, and you get 3. And then the next time you run it, I'm going to do I plus 1 after this. I plus equal 1, or I equals I plus 1. But then it's going to be 3 times 10 plus 5. Does that make sense? We're trying to get this number value. And this is this part of the problem. Okay. So now, maybe it's not a digit. We already calculated the digit part. So what if so what's this part right here? This is checking to see if it's an open bracket, right? So this is the part where we're going to do recursion on this one right here. So we do, what is it? And that gets overridden as, I call it DFS. Wait, did I call it index? Okay. I called it pause. I'm going to call, I'll just call this pause. Okay, so what I'm doing here, right? I am getting, the recursive part. So this part gets the, the sub-solution of this, right? And this part, IDX, gets the index value of this, bracket once we do all the work on 42 square bracket B. That's the point of that. And then we put it into here. We have to, I did it in this is list comprehension form. So I don't want to get too technical with Python because I might confuse them. Yeah. That might really confuse them if I did that. And actually, okay. Well, actually, I did not do this before. But before we have to get an empty array, and we can turn arrays of strings into one singular string, and I'll show you how to do that right now when this is done. But this list, right, this array can equal the array plus, so actually you will return what's inside which is local times num. Okay. Do you get this part right here? This one right there. All right. So local is a string, right? It's It's actually basically just what's inside the brackets. Okay. And we put it into another array. We put it into another list. And then we repeat that value in that list num times. So we're just repeating b 42 times. Okay? So it's going to be a list with 42 b's, and they're all strings or characters. And then obviously what we want to do is join. So actually this part ands plus, this is just adding it to the list, right? We're just adding all of this other list to the answer list. So the part was this. I equals, and this part I equals IDX, that's us wanting to leave this bracket. We're skipping this bracket, and we want to move on. Because maybe after this bracket, we have X, Y, Z, and we just want to add those. Okay? So then we would continue with this while loop. And then num, before num was 42, now it's going to be 0. Because maybe after this, we have then after, we're done with that one, then we get x and then 5. So we find another number. So that's why we have to return num equals to 0. Okay? All right. So I am kind of running out of space. I'll continue here. All right. So now we're going to return the tuple. It's going to be actually single quotes. Okay. Who has questions about this part right here? Okay. Yeah.
No, wait, that one?
Yeah. This part right here. You understand this part, right?
No, I just can't see from here.
Okay. You want to come here and?
I just need to wear my glasses, but they
Okay. So I'm returning a tuple, which is inside the parentheses. The first value of the tuple is the string, which this could be the sub answer, right, for a bigger one. And that's what that is, which at first is empty, but then we're doing work to this array. And then there's this thing called join in Python, where we get a string, it could be the empty string, and then we dot join it. So that means that we're trying to add all the strings inside an array. So and is an array. It's an array of strings. And this join is just going to make that all into one big string. Okay? Any questions on that? About this part? What join does? All right. Yeah, so well, that's the thing. So in Python, we wouldn't use append for a list. We would extend it. And inside extend will be another list, right? because we're working with a list, right? We don't want to append a list as one of its values. We want to append all the values of that list to our answer list. So that's what extend does. Maybe my handwriting is kind of wonky. I'm gonna write it better.
But the adding may work too, right?
Yeah, the adding works too. We're just adding all the values in the other list to this answer list. Okay? And so we turn that into a string. All the strings in the answer are becoming one string, and then we return I. I is the position where we found that it's the close bracket. Because we want to return that position so that here in this while loop, once we escape this recursive, call, and we go back to the bigger call, we put I equals to index, and so we're gonna do I plus plus, or we're adding 1 to I, so we skip every close bracket. Okay. These are all elifs, by the way. Elif means else if. So if this is true, do that. Else, if this is true, do this. Else, if this is true, do this. And the default case, else, is that what we have is just a letter, right? It's not a number. It's not the open and close bracket. It's just a letter. So we just want to add that. So we do and. Now we use append. And append just means to add a value to a list.
Why not use plus?
This is actually faster. In runtime, in Python, this is faster than the plus. Because the plus is like a whole, you have to override the operator of the plus sign in the list class. And that's like a whole lot of things you have to do under the hood. So now, after this, we do I. Well, I'll write it out completely. Equals I plus 1, right? So after all this if else if, we do I equals I plus 1. So we're just adding 1 to it so that we can get closer to the end. And then once we finish with all the while, which, putting the line there, we're going to return. And we just do this. Return. Yeah, I know. Okay. So at the end, we just do the same thing we did here, right? And I could very well be the length of the string. It could be that. So once, we're back outside, and I is the length of the string, we return 0, right? Which is the first value of the tuple, which is just the string of, our answer. Yeah, the answer. This is the answer for this one in Python. This is the Python answer for this one. Let me erase this if you're taking a picture. The problem on LeetCode is called decode string, which involves recursion. There's actually another answer that does not require recursion, which actually makes it faster because, well, it makes it less memory intensive. It requires less memory when you don't do recursion, and it has to do with filling up the stack, which is a whole, you'll get into that later on as you progress through your career. But, the recursive solution is a lot easier to understand, I think, than non-recursive solutions. But of course, recursion is, kind of hard to wrap your mind around at first, but then you practice and practice, and it just gets better. Okay. So this solution involved, recursively going to solve sub-problems, right? Like he said, we would go to the smaller one, and the smaller one, the nested one, right? And then we would do that first, and then work our way up. And that's what this is doing. And that was the point of using recursion in this problem to solve, what the actual string will look like. And the stack part, this is the stack part where it's a list at first. It's empty, but then, we append, characters to our answer. And then also here, right, we could also be appending a whole list of answers, a whole list of strings, given how many number it appears. Okay, any questions about what we just discussed? Any worries, any confusions that could be cleared up? Yeah.
Why did you multiply the numbers by 10?
Right here. This is I put the asterisk. Yeah. Because in the computer you would put the asterisk. Yeah. Here it is. So you multiply it by 10, right? It could be 0 at first, but then you add it by the integer value of that character, which could be a digit. So the only reason I'm putting int over it is because we find out that the character is a digit, right? If it wasn't a digit, then we would run this. And if it wasn't this, we would go here. And if it was none of that, then that means it's a character. So that's the default case. We add this character, we append it to the stack, right? We push it, right? I don't know how many of you have gone to stacks yet, but in stacks you can push to the top, right? And pop from the top. But here we're not popping anything. We're just pushing. So we're just taking advantage of this append. We're using it like a push. We push characters onto it. And then at the end, we return empty string join and the array of strings inside. And that will give you, one big string, because you're concatenating a list of strings. And we talked about this. This was the, if the return is outside, that means that I is going to be the length of the string. But we could also return when we find that we're at a closed bracket. Because when we're at a closed bracket, that means we're done with that sub-problem. And we have to return the index. We have to return the index so that we can skip that closed bracket, right? So that value, because the value is calculated in the function, but when we return the value, which is right here, we set it equal to index. We override our iterator I so that we can, because here in this while loop, let me see. So here's I at first, right? And then what we do is that we recursively call it, and then instead of moving I up by 1, we want I to end up here. That's what the point is. We want to change it to go all the way here, skipping all of these values. And that's why we return it here as a tuple. Okay? All right. Any questions? What time it is? Oh wow. We still have 10 minutes. We still have 10 minutes. I thought this would take longer. So I want to go over this other problem. The other one that was much harder than this one. Oh, by the way, this is a medium. This is a medium on LeetCode. So I'm just putting that there. I'm going to erase. Yeah? Okay. So there's this other problem which is a bit harder than this one. And it also involves strings. Okay. So there's this thing called regular expression matching. So let's say you have, so here's the rule. This period could be any character from A. Well, let's just say this is alphabetic, A to Z. And then we have this asterisk, right? And that's how the asterisk works. If we have A and an asterisk, then here are the different strings that this could produce, right? Could be an empty string, could be A by itself, could be A, 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 A. Any number of A's, right? So that's the rule of this asterisk. But let's say I put a B in front of it, right? Then that would change everything. I have turned this into a B. Since there is no asterisk in front of it, the B has to be here at the end of the string. Okay? Do we get how the rules of this regular expression matching and how this works? And let's say I put, let's do another A. What do you think that's gonna, what is that gonna do? If I put an A behind the other A, what's it gonna do? So, since there's no asterisk in front of this A, you have to put it at the beginning. I'm just going to put it for each and all. Okay? So the A has to be at the beginning and at the end, and in between the A and the B, there could be any number of A's, no A's, or 100 A's. All right? So that's the rule that we play by for regular expression matching. So I'm going to erase this too. You're given two strings, right? I think I'm just going to do the same one. So you're going to return true or false. Are these two strings a match? Think it over long and hard. Are these two a match?
Yeah,
Why?
because the C can not be there,
Mm-hmm.
then you have a multiple of A's,
Mm-hmm.
then the B.
Right. So the C can be there 0 times. So the A can be there 2 times. And this B right here, be here once. Okay, and we just add them up together and we get this. So yeah. Well, what about now? Are they a match now?
No,
No. Then why aren't they a match?
because they're on the same order.
They're not in the same order. But it's more than just that. I mean, yeah, that's true. It doesn't follow the rule, right? There is no B containing any number of A's and then B, right? Here it just says that you have C's or not, then A's, then B's. That's that regular expression right over there. And that's the rule that this follows. Number of C's could be 0, and then after that, the number of A's can be 0 or more, and then after that, the number of B's could be 0 or more, right? So the problem works is that you want to get a solution that reliably tells us if a string and a regular expression pattern are matching. Okay? Let's see how much time do we have. Okay, we have 4 minutes. So we don't have a whole lot of time, but
Do homework.
sure. Well, we could put it up, right?
Yeah, we could right now.
Put it up right now. So we're going to put up this problem right now on LeetCode, right? Speaking of LeetCode, we're going to start putting questions back. We've been on a bit of a hiatus with putting questions on LeetCode. We do apologize for that. Things have been hectic. But we are going to put them back soon. So you guys can do your daily LeetCodes, the beginner and the advanced problems. You put it?
You want to tell them the difficulty?
This question's a hard question. This is a hard question. The other one was medium, this is hard. So this is going to be put on advanced, which,
So how do we access LeetCode?
oh, so you have to make an account with
Create an
LeetCode.
account and then how do I look for it?
Oh, okay, so okay, so this is the problem. Well, he's going to put it on the Discord, right?
Yeah.
So if you want, are you on the competitive programming role?
I don't think so.
Okay, so yeah, show him how to do it. And so basically, on our competitive programming, well, if you're on the role, you can basically go to the advanced and the beginner problems channel, and also a thread for the beginner solutions. For the beginner problems has the LeetCode solutions that you can submit. With spoilers, of course, because we don't want to just give people the answer, right? So this one,
So we're now doing what is it like?
Developer community.
I think it's Matcher.
So you join the competitive program for this one?
We'll just look this up on the problems on LeetCode, and it's going to be this problem.
Okay.
And since today is the recursion day, the hint to solving this is going to be recursion. That is the only hint I'm giving you, is that this is recursion. All right? And another hint is that this is actually much like the Fibonacci problem. What did we do with the Fibonacci problem? What do we have to do to make it better?
Memoization.
Yeah, we had to create a memo table. All right? Now, of course, the memo table for this is not going to be exactly the same as the one for Fibonacci. It's going to be different. And that's your homework. All right? So solve it with recursion first, and then solve it with recursion and memoization. All right? So don't forget that this Friday we have binary search night at 8 p.m. to 10 p.m. So we're just going to code together, do not LeetCode questions, different website. The problems are a little bit more challenging, but you know, when you're forged in fire, you get sharper. I don't know, like a whole quote. Yeah, forged in fire.
Wow.
You are forged in fire. I don't know. Just it's supposed to be, yes, inspiring. But no, yeah, 8 p.m. on Friday we're gonna have our binary search competition night. We're friendly competition, no, you know, none of that pressure. It's gonna be hosted on the Coding Dojo too, so we're gonna be live. So yeah, that concludes today's lecture.